everyone, I'm Jacky. Today I'm gonna talk about metabolic energy demand and food utilization of the hydrothermal network, which named Xenograpsus testudinatus. Okay, so let's go to the introduction. What is the crab? In brief, I will name it X or crab. Okay. This is the Turtle Mountain Island, and this is the surface of the ocean. This is hydrothermal vent, and this is what you look like. What you look like, yeah. And the crab live near the hydrothermal vent about 200 meters, and the depth was about 8 to 20 meters. And the seawater environment has something like sulfur rich and high water temperature about 65 degrees Celsius to 116 Celsius, and low pH. And some trace elements like this, and some gas. This is all from the vent. And what does the expert eat? This is the zooplankton, and it looks like this, and they were killed by the toxic discharge, and they will fall down and eaten by the crab. But the food supply is discontinuous and poor, so the crab to store significant amount of lipids can be regarded as crucial in serving prolonged period of food depletion. And because of if we have sufficient food, and the crab will go to eat, but if they have lack of food, they will consume their stored lipid. And the enzyme in their body, there are two important things like digestive system and biochemical digestive features. Is an important clue about the feeding and nutrition of hydrothermal vent species. Some of the hydrothermal vent species digestive system of many sessile or sluggish deep sea are then degenerated, but certain symbiont like tube-worm, mussel, or clam. Oh, sorry. Okay. The anatomy of the digestive system and biochemical digestive features have provided major clues in understanding feeding and nutrition in hydrothermal vent species. Some of these organisms shows high lysozyme and chitolysis activities in midgut tissue due to bacterial feeding. And in contrast to these organisms, which can be considered primary consumers, there are predatory species show low lysozyme activity, but instead higher activities of proteolytic and the lipolytic enzyme. And the purpose is to extend our knowledge about the nutritional adaptation of the express determining of the energetic demand of the species by identification of the catalytic properties of important digestive enzymes, and aspect of energy storage and trophic preferences were addressed by investigating the midgut gland lipid levels, lipid class, and FA, which means fatty acid compositions. The material and method. Institute for Biodiversity and Academia Senior, in Chinese is 中研院. In 2007 summer, they catch 200 male specimens. Why we just catch male specimens? Because we want to avoid sexual difference. And the 200 species will get into 250 liters of tank and then filled with natural seawater and salinity, and we give them 12 hours of light and 12 hours of dark, but maintain the degrees of 24 Celsius. The starvation experiments, which want to make their stomach and their gland be clear, so they put them into 200 of the bottles about 500 miles individually, because they want to separate them and avoid they will be beat each other. Okay. And the first day we get 20 specimens, cut down the midgut gland and excise weight and immediately frozen in liquid nitrogen. And 10 of the midgut gland will use for lipid analysis, and the 10 of midgut glands will use to and then assess. And we will do the same thing every 10 days, and the total experiment will have 30 days. For gut morphology, and we have a specimen and we'll put in 3 plants, and we will have the SEM protocol, which means scanning electron microscopy, and we will put in the 0.1 molarity and wash 3 times, and we will put them into 1% of osmium tetroxide and 0.1 molarity of PB, which means for phosphate buffer, for 30 minutes, and we'll use the PB to wash. Then we will dehydrate it and we will coat it with gold, and we will do the SEM again with 25 kilovolt electrode field. And the lipid acid, the frozen midgut glands will lyophilize for 48 hours, and the dry mass was determined. The amount of total extractable lipid was determined gravimetrically on a microbalance and present as the percent of dry mass. It will write like this. And the lipid extract adjusts to a final concentration of 14 microgram per mile. And in DCM, we were used to determine lipid class composition using thin layer chromatography with flame ionization detection. And fatty acid analysis, we subsamples of lipid extraction, about 100 mg, were used for transesterification. After the evaporation of the solvent under continuous flow of nitrogen, a milliliter of methanotic of
2 minutes
acid
left.
and 250 milliliters of alcohol go to the sample, and mixture was under nitrogen for 4 hours at 80 degrees. 50 milliliters of sample were adjusted to a concentration of 0.02 microgram microliters. He examined and were then analyzed by gas chromatography. Fatty acids methylated were quantified by a flame ionization detector and identified by comparison with retention times of an established fish oil standard. The preparation of the crude in next. This is a midgut gland, and we'll put into this one. And this is a machine to cut it down and to a small slices, and we will do it three times. So, and we will throw it into the this machine to separate the something, and we will put it to a different bottle. And its name determination centrifuge, and okay, we will.
Okay, stop. 12 minutes. QA. Sky.
She dropped the phone.
All right. Right. Ryan. Shen. Sam. Tell us. Stella. Okay, in this order. Starting with Frank.
What is your conclusion?
My conclusion is the expert exhibits physiological adaptation to successfully inhabit a highly challenging environment. The fatty acid in midgut gland is important when food shortage, because if they have no food to eat, they will use their fatty acid to maintain their life. And the enzyme in expert has high endurance level of environment, because the seawater is very acid and high temperature.
All right. Chen.
And what is midgut gland mean?
Midgut gland is mean the crab has its gland. You can imagine this, and midgut gland is about the middle of the place, and in Chinese it named 中长线体. He has many many enzymes to digest the food. Okay.
All right. Next, William. Oh, right. Sorry. Is that right? Sam.
In a liquid analysis, what is ECM mean?
Liquid analysis. ECM. Sorry, it was in the paper, but I don't really write it down. Sorry.
Tell us.
In your method and the material, you say you frozen them. Yes, you did.
Okay.
You froze the crab, the old crab, or only the
No, just the midgut gland.
Oh,
Stella.
For the next slide.
This
What is,
slide?
yes, is what is forgot morphology? What it is to what is it used for?
Sorry, repeat
What
again.
is forgot morphology and what it is for use?
You mean why I will do this?
Yes.
Sorry, I don't know why they will use forgot more biology. Sorry.
Alright, on to your question, Annie. 1, 2, 3, 4. 1. Okay.
You say you have the medium graph,
Yeah.
but is the medium graph to reform, or you do the same thing everything? There's a medium graph.
Wait. Speak slowly.
You cut down the graph on this graph.
Yeah.
So is this graph reform again, or you just cut
No.
every 10 days?
You mean if I cut down the gland, the crab will survive or die?
The graph in the crab is less than that.
We will kill the crab and get the gland.
Okay. Alright. Good. Second.
Are the crab only in the island or and already in other environments?
You mean are the crabs living in other extreme environment? I don't know, but I guess they just live. This kind of crab just living around the hydrothermal vent because their enzymes are adjusted to live in this area.
Okay, so what's the thing? Okay.
In the material page, you said that you must avoid sexual difference, so you only choose male as X-crab. So what is your method to protect this male X-crab? Besides, don't you think that only 20 sample is too empty to prove they can use?
Can you speak again? Slowly and easy.
How to collect these male X-crabs?
You mean how to why just a male or
How to collect?
How to identify?
identify? The paper didn't write it, but it must have some appearance to look outside, or they'll have some sexual difference when
Right.
they're looking.
Okay. Right. What's the name? Okay.
I want to know what is the lysozyme and the chemical activity in their
I can't
in this
hear you.
crab.
I can't hear you. Sorry.
Lysozyme activity.
Active.
In this crab, the relationship is
Where? Oh, you mean
this lysozyme and activity.
It is a pro in enzyme and
What is the function?
functions. Sorry, I don't know.
Okay. Better. So I think you are aware of that yourself, that called is time control. So you use up the whole 12 minutes without reaching your data. So next time, I would say there are two, I think related to this problem is the lengthy introduction and lengthy description of the method. So next time, my suggestion would be, so let's see. I think that the starting part is all good. So you talk about where to find these crabs and what kind of environments. It's all nice. However, starting at some point, we start to see this kind of slides. In my opinion, when I start to see this kind of slides, that really means these are text from the paper. Is that right? Which means it's sort of like a sentences from the paper, and you did not sort of explain in your own words. So here we have 1, 2. Okay, actually, okay, these are all good. Then we start to see this, and many other this. So I would say when you talk, if you want to introduce enzyme, maybe the question of Edgar would be a good guideline for you. That would mean you talk about in this kind of situation, what kind of enzyme would be interesting to us. Then you have these keywords like lysozyme, proteolytic enzymes, and lipolytic enzymes. Have you learned biochemistry? Usually if you have some training in biochemistry, you will know what this means. And if not, then I would say try to use Wikipedia and tell us what kind of organic compounds are these enzymes dealing with. Because that will be something you need to tell us later when you introduce your data. Like a proteolytic enzyme means enzyme that cut down protein. And lipolytic enzyme, that would be enzyme that degrade lipids. So easy, that's simply so. Okay, and then another key problem would be, of course, you spend a very, very lengthy time explain all these analytical details. In my opinion, this can be all condensed to one slide. You measure this, that, and then you go directly to results. Because the data are more interesting than the analytical detail. So these analytical detail can be all skipped. Okay, and then next time, if you can condense your slides and tell us more about the interesting data and the interpretation of the data, then it would be great that you try to speak with up and down. Avoid monotonous 单调的 description like the semi-quantitative enzyme screening of midgut, gland, extracts of extra reveal, blah blah blah. That would be a little bit make people sleepy. Okay, and of course this is a biochemical study. It looks like a biological study, but actually it's chemistry. Which means you really need to explain difficult terms, and these terms cannot be explained by photo. For example, again regarding the question of agar, you need to explain why you choose this enzyme and what these enzymes are useful in the crabs. Okay, spend some time to explain that instead of the analytical detail. Okay. Yeah, that would be my, okay. And there are some pronunciation issue, like sufficient and enzyme. Enzyme, we usually read enzyme, not enzyme, okay. Yeah, my main suggestion is, once again, so condense introduction, material methods, and then introduce enzymes. What kind of enzyme, what are they useful? And try to stick into your data and discussion next time. Okay, so let's thank Jacky.